All right, well, that concludes our discussion of a variety of different tests for checking whether a given infinite series converges or diverges. And so in this last video, before we move on to power series, I want to take a moment to discuss how do you know what the right test is going to be? How can you actually choose a test for a given problem? Okay, and we looked at some of these earlier on. So the nth term test, it's pretty much always a good idea to try it, at least to think about it. Even if you don't work out the limit by hand, you can often, use a calculator, say, to estimate what the terms are approaching to get a sense of whether you think that's likely to be helpful. Telescoping and geometric series are very negative or very narrow classes of series. So telescoping, most often they come up when you have terms that look like some function of n minus some function of n plus 1 or something related to that. And then geometric, of course, is when you have some fixed constant r raised to the nth power in your terms. And so those ones you'll often be able to recognize by sight. Beyond that, we've got the ratio test and the root test, which we just discussed. And the ratio test tends to work well when their terms are made up of products of things, because when you have products and you divide two products, a lot of things can potentially cancel. And that's particularly convenient when you have factorials, and factorials are also problematic for many of the other series tests. And so if you have a factorial in your limit that, or in your terms, it may be a clue that the ratio test would be worth trying. And then the root test, pretty much it only is going to work well if your function, if the terms themselves have the form some function raised to the nth power. So for the most part, the root test is either going to give you a really, really nice limit or a really horrible one. And so opt for the root test when you see something raised to the n. All right, then we have our comparison tests. And those were when we had positive terms that were decreasing and continuous. And then, of course, the best scenario for comparison tests, it's not the only one, are where you have sums in the numerator and denominator, and those sums would allow us to argue that, well, not all of the terms actually matter, and so we were able to come up with something to compare to, often by neglecting some of the terms in those sums. So it doesn't only work for sums, but that's often a clue that a comparison is worth thinking about. We talked about the alternating series test, which is appropriate when we had terms that alternated between positive and negative. And so they were written in the form -1 to the n times some positive value bn. We had the integral test, which works well for series with positive terms, but it was only useful, of course, if we could actually evaluate the integral. And so functions that have things like logs and powers of x were often suitable to use the integral test. But if we have a really, really complicated function, or we have factorials or many different exponentials combined with n's, then potentially the integral test is not going to work. And then lastly, we also had the p-series, which was really just a corollary to the integral test. And that showed us that when we have 1 over n raised to a p, we know the answer. Okay, so if you understand how to use all of those tests, then you're going to be in good shape for a couple of our objectives on the next batch of exams. If not, then I would recommend going through chapter 10.5, which has a whole section of problems that says, hey, pick the right test, as well as the chapter 10 review section, where they've got, again, a whole bunch of series where you need to first identify the appropriate test to apply and then determine whether you have convergence or divergence. And of course, the odd answers are in the back of the book. And I'm sure you can find answers to the even numbered problems as well if really necessary. So hopefully you can get some good practice related to that.